to this. Okay, so we talked about last class period taking all of our points, lines, and planes, specifically lines, and breaking them down into smaller chunks. We did line segments, and then we figured out distances, midpoints, all that sort of stuff. All right, going forward today, we're going to do another smaller breakdown of a line and then use it to build angles and learn all about the angle relationships. There's going to be a lot of this stuff today that you've already seen before, okay? And there are a lot of examples at the end. The first part of this is a lot of vocabulary, and then we're got to get to a lot of examples at the end. I want us to have time for the examples, so we got to get through this vocabulary section quickly. That's why all the definitions are written for you. You're responsible for mostly pictures on your paper, okay? So can you open that for me and just set it there? Thank you. All right, so try and keep up with me as quick as you can on these pictures. I'll be describing and talking about things as y'all are drawing. Okay, so a ray is another portion of a line, but instead of having two endpoints, it has one endpoint and extends infinitely in another direction. Now, a ray is much more specific on the way that we name it. When we name a ray, we have to always use the end point first and then another point on the ray second. And then our ray symbol always faces to the right. It does not matter how the actual ray is oriented in space, on the paper or in the plane or anywhere. We always write the end point on first and then the other point second, and the arrow always points to the right. So if I had this one here as A, B, C, I can name it AC or I can name it AB. Either one works. Notice the endpoint's on the left, arrow faces the right. Sound good? Okay, opposite rays are two rays that share a common endpoint and are collinear. Here we're using J as an endpoint. We got JH, ray JH, and ray JK being opposite rays because they both are on line L. Opposite rays will always form a straight line. So for your picture here, just draw the picture and you can just write JH and JK and you're good. Okay, a vertex is the point of intersection of two rays or segments. We use that to form angles or also eventually to build those angles together to make shapes. Here, point A is the vertex in both the angle and in the triangle. All right, an angle is always formed by two rays, also known as sides, that share a common endpoint, which we call the vertex. Now, we've also got to talk about the way that we name angles here. So, on this first one, we're going to call this angle B. There's the angle symbol there. Looks like a less than. You don't have to draw the angle arc inside of there. That's also appropriate. I tend to write that curve there, or the arc there, just so that people know it's not a less than sign. Now, when there is only a single angle at any given vertex, you can name it just by the vertex. However, if there are multiple angles at the same vertex, you're going to have to be more specific when you name it. So, for example, this angle here that I'm marking with purple would be angle ABD. Notice that the vertex is in the middle. That is required. The other two can be flopped around. So you could put angle DBA, would also be fine. Now if I take this blue angle, that would be angle DB. I said it right, I wrote it wrong. Angle DBC. And then what if I took the greater angle, the biggest angle? What would I call that one? angle ABC, or CBA. Either one works. All right, easy enough at this point, right? Okay, name all of the angles that have angle B as a vertex. There are 4 of them. And we've also got another naming convention I didn't mention on the previous page, or the previous slide. So first off, those numbers inside of there. If you have a number inside an angle that does not have a degree symbol on it, that is also a name for the angle. So we've got angle 5, angle 6, and angle 7. And we've also got angle GBA. Now, we're not always going to do this, but just for the sake of being complete here, just like line segments, just like lines can have multiple names, angles can too. So what would be another name for angle 5? GBE, as well as angle GBF. Because ray BE and ray BF are the same thing, so you could use either one B or F to name the line, or to name the angle. Also for angle 6 over here, we could name that angle DBE or angle DBF. And then for angle 7, our only other option there is angle ABD. All right, so lots of ways of naming angles. I'll jump in and out of all those different possibilities just based on whatever happens to strike me at the moment. All right, any questions on naming? All right, name the sides of angle 5. So remember the sides of the 2 rays that make up angle 5? So what are our 2 rays that make angle 5 work? Or that create angle 5? Okay, ray BG. Thank you for using the proper terminology there. Ray BG. What else do we got? Yes, BF works. Another name for BF is also BE. Yeah, ray BE. Either one is appropriate there. All right. Sorry, y'all. I'm going to sit down. I'm tired. All right. Example 3. Run another name for angle 6. So angle 6 is over here. What's another name for that? DBE. Also, we could use DBF. All right. All right, measure of an angle. That is always going to be the smallest amount of rotation about the vertex, meaning that essentially I've got a little pivot point right here. How much am I rotating to get to there? It's measured in degrees. Now, I want to point out that just like in measuring lengths, there's different, and lengths and weights, you've got different measurement systems. You know, metric versus customary. So inches versus centimeters, kilograms versus pounds. There's also another system for measuring degrees called radians that you will get to quite a bit when you get to pre-calculus. However, we are not going to do anything with radians other than the fact of you knowing that they exist, because when we get to second semester and we're doing stuff called trigonometry, your calculator, when it's doing trigonometry, it natively understands, its default is radians. And we're going to have to take extra steps to convert it into degrees. And so I need you to know that radians exist. you'll learn how to use them in pre-calculus. Okay? Also, always between 0 and 180. In theory, I could go the long way and measure this direction, but we're not going to do that. Okay? Again, that's a pre-calculus concept. Okay, two angles are congruent if they have the same measure. So, for example, if this guy was 40 degrees and this guy was 40 degrees, we would say they are congruent, still using the same congruent symbol from last class period. Now, those are marked in a drawing with angle arcs. So you could have, this arc here tells me that these two are congruent to each other. Now, another way that you could see that is, sometimes we'll do multiple arcs if we're trying to do more than one in the same drawing. So that'll happen sometimes. And another way of doing that would be with hash marks. So I could do a one mark, 2 mark angled measure. Sorry, a whole bunch of this entire first unit is just learning notation. Okay, an angle bisector. Bisect also means, just like last time, cut exactly in half. Shorthand, you'll see me do this sometimes. B with a circle around it stands for bisector. Okay, still cutting exactly in half. And notice we got two angle arcs here to show they are equal. Okay, so it cuts the angle exactly in half. But the bisector needs to be a ray. Technically, a plane can also be an angle bisector. But you can have a ray or a segment or whatever, as long as it shares the same vertex and cuts the angle exactly in two. All right, parallel lines are lines of the same plane that never meet. They have no intersection point. They run side by side. The symbol for parallel, anybody know what it is? Has anybody seen it before? I'll give you a hint. It's in the word parallel. Two vertical lines. Okay, so it's two vertical lines like this. So to say the two lines are parallel, I would say A is parallel to B. Remember how I told you that symbols in geometry always look exactly like what they're talking about? Okay. Perpendicular lines are ones that meet at a 90-degree angle or a right angle, and the symbol is the upside down capital T. So here I would say that line AB is perpendicular to line, that should be AD is perpendicular to line BC. All right, skew lines. I mentioned this briefly on Monday. That would be here like line CD that I'm highlighting, as well as FE. Two lines that are non-coplanar that do not intersect. Now notice non-coplanar is important there, because remember when we were reviewing our quiz earlier today, I said that even though it's not drawn, you could technically have those two corners opposite sides of the box, that the plane wasn't drawn, but they are coplanar. If you could possibly make a plane that goes through them, then that counts as coplanar, okay? So these two are non-coplanar and they do not intersect. They miss each other. Okay, right angle is a measure who is exactly 90 degrees, and we have that little box symbol in the angle arc, okay? This guy right here. Be careful of assuming that things are 90 degrees. If it is marked as 90 with a box in it, I don't care if like my artistry is a little bit imperfect and I drew an acute angle and marked it as a right angle. If it's marked as a right angle, it's a right angle, okay? Also, do not assume that just because something appears to be right, that it is right. Because I mean, it could be 89.5. It could be 99.5. And the difference between 89.5 and 99.5 is so minuscule that the eye can't detect it, but it's a difference between right, obtuse, or acute. Okay, so don't assume. Only if it's actually marked as such. Okay, an acute angle is one whose measure is less than 90 degrees, including things like 89.9999 is still less than 90 degrees. So probably should have a, oops. Degree symbol there. An obtuse angle is one that is bigger than 90, but less than 180. Okay, classify as right, acute, or obtuse. All right, so MPR is this big angle. Obtuse. RPN is right. And NPS is acute. Easy to tell because that right angle is marked. Okay, I'm going to skip. No, I thought I had more there. Never mind. Okay, adjacent angles are angles that lie on the same plane, have a common vertex and a common side. So angles 1 and 2 on both of these are adjacent. They share a common vertex as well as a common side. Okay, vertical angles are angles formed by two intersecting lines or rays or segments that share a common vertex but not a common side. So here angle 3 and angle 4 are vertical angles. Notice the word vertical here is different than what you're used to as the up and down direction. Okay, it means they're across from each other with two intersecting lines. Now, and the other thing is that the measure of angle 3 is congruent to the measure of angle 4. By the way, it's the first time I've thrown out the little M. This stands for measure of. How many degrees is it? Actually, take it back. The measures are equal. However, the angles are congruent. Slightly different notation, but either way, the measures are the same. Also, angle 1 and angle 2 are vertical angles, therefore they are congruent as well. Oh, by the way, vertical angles is one of those vocabulary words I need you guys to have down very quickly. We're going to be using vertical angles a lot throughout the year. Okay. Also, the idea of you see vertical angles, you have to automatically go to the idea of this equals this. Okay, one angle equals the other angle. You got to be able to make that jump very quickly. Linear pair is another one that we're going to be using very quickly and using a lot. Those are two adjacent angles that form a line. Okay, complementary angles are two angles that have whose sum is 90 degrees. They can be adjacent or non-adjacent, does not matter. Either way, anytime you have a set of complementary angles, there's going to be this base equation that I expect you guys to be able to pull out of thin air. You see a picture like one of these, and I expect you to be able to come up with something plus something equals 90. Measure of angle 1 plus measure of angle 2 equals 90. Okay, and be able to use that for algebraic manipulations. Next one is supplementary. Angles that add up to 180 degrees. So here, angle 3 and angle 4 are supplementary because they make a straight line, or because they are a linear pair. as well as angle P and angle Q are supplementary because 120 plus 60 equals 180. Again, base equation here, something plus something equals 180 degrees. We'll be throwing out that equation a lot here in the next few minutes whenever we are doing examples. All right, and here is just the idea of that. Same thing we talked about before. Something plus something equals 180. Okay, example 5, identifying. Name the pair of angles that satisfy each condition. Give me some vertical angles. So somebody first, give me one angle that has a vertical on there. Which one? Angle ABC. ABC and what's the vertical one? The one that's made by the same two lines? Over here. I got to throw another point there. Let's call that Z, just so I need it. So we got angle EBZ. All right, two adjacent angles. Let's use angle GFH as our first one. Give me an adjacent angle to angle GFH. Or what's adjacent mean? They share a vertex and they share a common side. So yes, would you say EF? EFI will not work because EFI is vertical with it. It has to share a side. EFG would work. All right, two supplementary. How many degrees is supplementary? They sum to 180. So let's just go with angle. Let's do GFH again. GFH and? Yeah, EFG works again. Linear pairs. All right, now complementary angles. Ones that add to 90. There's only, two named ones here. Angle CBD and DBE, because these two together make a right angle. All right. We already did one like that. We're going to skip 6. All right, 7. Find the values of X and Y. All right, whenever I'm doing this, I'm looking for patterns that I can deal with. For example, I see that both of my ones that have X's in them looks like they form a right angle, so they are complementary. So my equation there is measure of angle TSU plus the measure of angle BSU is equal to 90. Remember how I said last time that we can have more complex variable names in geometry? Yeah, measure of angle TSU is a variable there. All right, so let's start plugging in. Measure of angle TSU is 5x plus measure of angle VSU is 4x equals 90. Which now simplifies down to 9x equals 90. And then divide through when I get x equals 10. There's one of my answers. However, I also want to know X. I want to know Y. And so when I look at my Y here, the only thing I'm seeing as a common relationship is it looks like that angle RST and angle TSU are a linear pair, which means they add to how many degrees? 180. So the measure of angle RST plus the measure of angle TSU equals 180 degrees. Okay, therefore, I'm going to substitute in RST is 10y plus 10 plus 5x equals 180. But now I can't have an x and a y in the same equation. Well, not with a single equation. There could be a system I could do, but... So I'm going to take this x equals 10 and just substitute it in. 10y plus 10 plus 5 times 10 equals 180. So that gives me 10y. Let's see, 5 times 10 is 50 plus 10 is 60. Subtract off my 60 gives me 10y equals 120. And therefore y equals 12. All right, questions on that one? All right, 13 more examples to go. And we got 16 minutes left. Okay, no, we're going to skip around. All right, find the measure of angle 1. Well, here, the measure of angle 1 plus 72 equals 180. Why? Because they're a linear pair. So that means the measure of angle 1 is equal to what? 108 degrees. Now for x. I know that these two are a linear pair, meaning they're supplementary. Well, if this guy's a right angle, this one's also got to be a right angle. So 10x minus 24 equals 90. Add 24 gives me 10x equals 114. Therefore, x is 11.4. All right. Now we've got to find y. Notice here that the 72 degree angle and my angle with the y in it are vertical angles. What do I know about vertical angle measures? Look back. What did I say about them? This is one that I need you to know. They are equal. Thank you. Equal. So 72 equals 8y minus 16. Adding 16 to both sides gives me 88 equals 8y. Therefore, y equals 11. There's my three answers. All right, so this one's a little bit different just because there's three angles here. Measure of angle 3. Find the measure of angle 2. We want to find this one. If measure of angle 1 is 30 degrees and measure of angle 3 is 85 degrees. Well, subtracting what? Yeah, technically, I mean, what we're going to do here is 85 plus the measure of angle KGH plus 30 equals 180, which, yes, the effect is, yes, just subtract them from 180. So I got the measure of angle, well, I guess that should be, I'll name it easier. Measure of angle 2 Let's see, 85 plus 30 is 115. 185 minus 115 is 65 degrees. I should have just said angle 2 for that one. All right, here we've got the word bisects. GK bisects angle MGF. So when GK bisects MGF, that means that this angle equals this angle, and the measure of angle 2 equals 45 degrees. Now, since MGF is a straight angle, it's one continuous line, well, if it bisects it, then that means that these two have got to be 90 degrees. And then if this is 90 degrees, 90 plus measure of angle 1, 45 plus the measure of angle 1 equals 90. Therefore, the measure of angle 1 is 45 degrees. All right, let's skip number 11. I want to get on to bigger and better things. Skip 12. We're on the back of the sheet now. All right, let's do 13. Measure of angle 1 is 14 degrees. Measure of angle 3 equals 100 degrees. How am I going to find the measure of angle 2?
100 plus 14. Subtract that from 180.
Okay, so the answer that one of my students gave me was add 100 plus 14 and subtract that from 180. While it is technically mathematically correct, I'm going to go ahead and get you guys used to writing out the algebraic equation at the beginning, because it's not always going to be that easy. Okay, we need to practice writing those equations out. So yes, the effect though is measure of angle 2 plus 114 equals 180. Then subtract 114, gives me the measure of angle 2 is equal to, what, 66? All right, skip 14. That's it's a simple subtraction problem. Okay, 15, we're going to skip it, but the easiest, or the thing I want you to notice here, since it says QYR is a right angle, go ahead and mark that as right. And then once you've marked it as right, and then VYR is 53 degrees, it becomes easy to subtract those and get this guy getting 27 degrees. I guess, never mind, I did it, but we're not going to spend time on it. Okay, 16 is where things started getting more complicated. We have algebraic expressions in here. Angle QYV is 4x plus 20. VYR is 6x plus 8. And QYR, the greater angle, is 148 degrees. So our equation, measure of angle QYV plus measure of angle VYR is equal to the measure of angle RYQ. Now, angle QYV is 4x plus 20. VYR is 6x plus 8. And then RYQ is 148 degrees. We all right with those substitutions? Okay, situations like this is why writing down the entire equation is beneficial to you, so you can help start seeing improper substitutions and that sort of thing easier. Okay, so now 4x plus 6x combined like terms gives me 10x plus 28 equals 148. Subtract the 10 or the 28 gives me 10x equals 120. So x equals 12. All right, this one is fun. All right. Guys, please pay attention to this because this might end up on your homework or on a quiz at some point. All right, measure of angle STA. Now, STA is this larger angle. Is congruent to the measure of angle PTR. Notice there's an overlap there. And that the measure of angle 2 is 20 degrees. Now, does it make sense that let me go switch to orange here to color code it, that the measure of angle STP, which is this, oh, I'm sorry, let me reset this. The measure of angle 3 plus 20 degrees. Okay, what did I just do there? Measure of angle 3 is this angle plus 20. What did I build there? That equals the measure of angle STA. Do the exact same thing in blue. The measure of angle 1 plus 20 degrees equals the measure of angle. What do I do when I measure at angle 1 plus 20 degrees? Is what? Is PTR. However, STA and PTR are congruent, correct? So I could essentially make this substitution. The measure of angle 3 plus 20 also equals the angle of PTR. Are we all right with that substitution? Because these two are equal to each other, there's my equality substitution. And now, since this equals PTR and this equals PTR, I can say that the measure of angle 3 plus 20 equals the measure of angle 1 plus 20. And now what happens when I subtract 20 from both sides? Measure of angle 3 equals the measure of angle 1. Now, while it may have looked that way, we didn't know that for sure until we were able to prove it mathematically. Okay? So we know that the measure of angle 3 equals the measure of angle 1. So now I can jump over here to a side calculation and say that the measure of angle 3 plus 20 plus the measure of angle 1 equals 180. Right? Those three together all equal 180. However, measure of angle 3 and measure of angle 1 are equal to each other. Therefore, 2 times the measure of angle 3 plus 20 equals 180. Okay? I did that substitution in to get this. Subtract 20. 2 times the measure of angle 3 equals 160. Divide 3 gives you measure of angle 3 equals 80 degrees. How's that for some algebra right there?
Ow.
Anybody brain of an aneurysm on that one?
That one hurts.
Hey, you know what? Write it down. Go back and study it later.
No.
Or you can watch the video.
No. I'm watching the video over and over again.
Okay, we're done. Keep going. Let me see which one of these I want to do. All right, let's finish up with 19. Okay, if the measure of angle R, or find the measure of RST, so I want to know this one. Now, in order to know that one, I'm probably going to have to find both X and Y in order to find it. Okay? So, it says that ST bisects RSU. So if ST bisects RSU, that tells me that RST and TSU are congruent. And SU bisects TSV. So TSV, SU bisects it. Hey, those three angles are all exactly equal. Now we're going to hate me for this one. Here we go. X plus 2y minus 1 equals 6x minus 9. I also know that 6x minus 9 equals 2y plus 5. Okay? That came from the top equals the middle, and the middle equals the bottom. I've got two variables in both those equations. Anybody remember from Algebra 1 how we solve an equation that has two variables in it? You got to use a system. So I'm going to collect all my x's and y's on my variables on the left and everything else on the right. So let's do our green equation first. I'm going to subtract the 6x. That gives me negative 5x plus 2y equals, add the 1 to the other side, and it gives me negative 8. Oh, wait. There should have been a 2y. Okay, similar idea with this one. I want all my variables on the left. So 6x minus 2y. Now add 9 is going to give me plus or equals 14. Are we okay with those two manipulations? Variables on one side, numbers on the other. Now, I'm just going to stack them on top of each other to make a system. Negative 5x plus 2y equals negative 8. And 6x minus 2y equals 14. And we always have that little brace when we're doing systems, right? Now, there's multiple methods. Substitution, elimination, graphing. I am going to use elimination here because I have a positive 2y and a negative 2y at the same time. Add the two equations together. Negative 5x plus 6x is x. These two cancel out, and that leaves me with negative 8 plus 14 is 6. X equals 6. Now, take that and plug it into either one of your original equations. I'm going to plug it in up here. 6 times 6 minus 2y equals 14. 36 minus 2y equals 14. Negative 2y equals, subtract 36. 14 minus 36, help me out.
22.
Negative 22. Therefore, y equals 11. And then I trust y'all can plug back in from there. Okay? Plug those two into there. All right, class is over. I'll see y'all in 2 days.